So first is I told you uh, those three four methods. I don't know whether in A level they teach you how they allow the scale diagram. I think it's more of maths there. Okay, but I will look. First, you have to understand the question. The question is, it is about velocities. Okay, velocity. So whether it's displacement or its force or its velocity or if it's acceleration, everywhere if you add two velocities or two displacements or two force, you have to use the vector way, because here you have to also consider the direction is very important, the direction, and the best way is geometry, and geometry is the scale diagram, but that we have to be very precise. That way doesn't work, because if you're not drawing properly, you make mistakes. The other thing you have to understand is this is maths, that okay, I will add, but you have to understand the logic behind the question. That's the most important and the most critical thing. Otherwise, everything is messed up. The first is, he says there's an aeroplane, and the aeroplane is going north, is heading north now, and the wind is blowing. So this means that this speed of the aeroplane, the speed of the aeroplane will change now, because he is and he will you will have a resultant magnitude of the aircraft. So that means this north, the north he is going at, is he is going assuming that there is still air, there is still air. So that means there's no air, or there's still air. So this speed of the aeroplane going is called velocity of aeroplane with respect to the air or the wind, because there's no wind, then you say with respect to the wind. And this is the velocity of the wind. And you have to find the velocity of the aeroplane with respect to the ground, the actual velocity. So in terms of physics, we mean that the aeroplane with respect to the ground is equal to the velocity of the aeroplane with respect to the wind plus the velocity of the wind. That's how we interpret the question. That means ultimately what will happen is the aeroplane will have a new velocity. He's flying with respect to still air, but he doesn't realize there's air is blowing in some direction. So this is the maths. Then how do you understand this? Okay. Now you start making these vectors. You know that this is the resultant of these two. So you will have to draw these two vectors. So we have got two ways. One is the parallelogram way, and the other is the triangle way. So triangle way, wind, aeroplane. We got two vectors, this vector and this vector. So first, aeroplane with respect to the wind is going here, this, and wind is here, and 45 degree with respect to, because if you make it like this, even this will be 45. If you I've just moved them to for applying the triangle law. Look here, that they have tried to confuse you. They have made those two directions pointing. The tails, the heads are meeting. So what we do is we try to shift it so that the tail and the head are meeting, and this is the resultant. This is the result. Now the point is, how do you do this? Of course, the scale diagram is possible. Acha, this is one way. This is the triangle method. The other is the parallelogram method. So in that case, it will be, you'll have to draw the this thing here, the aeroplane and the this here, and then the diagonal will give you the and the diagonal will be very it will be um, if I keep the arrow length same, it will come out to be the, I mean, proportional. Like, see, if I make this here, I'm going to make the same length, and the wind, I'll make it go like this, and then I will try to complete the parallelogram, and this will match with this. So even if you take the triangle law, or the parallelogram law, they will come same answer. But we don't do it like this, we do it through mathematics. So there are two ways. One way is you know the angle between these two, or you know the angle between these two. So this angle is slightly different now. This angle is, this is 135. Okay, because if this was if I put the tails together, if I put the tails together, then it will get different. It won't be 45 anymore. I have just shifted this here, this here. This is the tail, this is the tail. And if this is, if you make, this is going to be 45 and this is going to be 90. So this is going to be 135. And then what you can do is you can just, if you know a formula, you can just apply the formula and get the answer. The answer is a square plus b. This is a formula. This you can be derived. How? In terms of components, you can say this has got two components. A b, if I place it here, this is b cos theta, and this is b sine theta. So and then this is the resultant vector. So this would be the Pythagoras theorem, because this is 90 degree. This would be a plus b cos theta whole square, and a b plus b sine square theta. If you do some maths behind it, if you open this, it will become a square plus b square cos square theta plus 2ab cos theta, and this will become sine square theta, and this will become b. And if you take out common, b common, it will be cos square theta plus sine square, that's 1, and you get a square plus b square is equal to 2ab cos theta. So this way, you know the value of a, the speed of the this thing, which is 250, 36 and 250. So what you can do is you can put 36 here, 250 here, whole square it, and the cos theta AB here, 36 and 150, and the cos theta is 135, and you get the answer. So this is the analytical way.